All right, what's up again, everyone? It is like multiple streams of live streams today. First couple was about fish, but now I want to talk about something that I've actually been working on most of yesterday, probably for a few hours. I shared a post about it, but now I'm actually going to walk you through and do like a live demo of it, what I'm building. I imagine this will take a bit of time as this kind of matures. So let me share my screen. Should look very familiar to a post that I made yesterday. Let me hide my screen there. Okay. So what this is basically a way of identifying healthcare providers that are of a different ethnicity. Really starting off probably more so from personal experience of like trying to find healthcare providers that can interact with my family members who primarily only speak Cantonese or Mandarin. And so it's kind of a challenge. And so I wanted to figure out, is there an easier way to do that? And one of the ways I was thinking of, there is a directory of providers. And this is the MPPES. Share more about that in just a second. That we could probably use to find all the providers and then locate them based on their geographic location. So that's kind of the idea is, as a caregiver, is there a way for us to identify providers based on geography? If you wanted to, you could by name, but primarily by geography, and it will search some real-time updated database to locate those individuals. The thing is, this directory of individuals doesn't have, uh, at least to my knowledge, languages spoken. So that seems to be missing in there. And the race and ethnicity seems to also be missing as well. So for my purposes, I won't be able to use it directly, but at least I can get an updated list of all providers within a specific geographic location. Granted, again, I believe there's general problems with provider directories in that it's not always that well up to date. So the geographic location, I think, is also a hit or miss. So there's some more things that need to be figured out with this. But with that, let's just say it is updated. From there, I was thinking about enriching it with a predicted race and ethnicity based on the provider's first and last name. And then even from the first and last name and the race and ethnicity, can we predict the language spoken to enrich the data that we get? And then ultimately, because sharing information about healthcare via FHIR is really important. So then converting what we get here into a format that a lot of other people can use. And in this case, it's FHIR. And in FHIR, we would have a practitioner to represent the practitioner, the role to represent the role, because we probably want to find providers by a particular type. Maybe it's like a primary care physician versus a geriatrician or a pharmacist or a nurse, something like that. And then there probably should be another one where it's like person that represents the race and ethnicity, but that's not in here, or at least not in my script right now, but that'll probably be part of it. And then finally, the user, once they do the query, they're just going to see this at the very end, which is a list of providers that meet their criteria. So that's kind of the goal for the project. And so if I go to this tab, this is the NPPES NPI registry. Everyone that is a licensed provider uh, must have a NPI. There are certainly certain stipulations with that, but for the most part, if you're looking for a healthcare provider for a family or friend, usually the providers you're looking for have a registered NPI. So you should be able to find them in here. And so I have myself listed. Just FYI, this is like outdated information, which is, again, one of the problems with these kind of directories. My information that's displayed, this is all public information, and it is outdated. So don't bother sending me email or phone number or calls here because this is all outdated information. So I'm looking myself up, and what this registry will show me would be these individuals. I'm actually going to go to something else, someone else. This is another Brian Fung. They have their MPI number, when it was last updated, details about all of these things. This is an individual, their mailing address, primary practice, and then these are the addresses we actually use to locate providers near like a zip code or a state. And then we would use the taxonomy to classify that provider by what the users are looking for. So that's kind of the idea. And MPPS has an API, and that's what we're going to be using. This is the version 2.1 to retrieve all those information. So they have a bunch of fields that they will send back to you when you query their API. So that's kind of the idea. I'm going to go to the notebook where I have this running. It's not in a GitHub repository or anything right now. I've just been kind of tinkering with how feasible this is. And this is just kind of my own notes, so not very important. The big thing here is going to be this library, which is trained on US Census data on predicting a individual's race and ethnicity based on how previously individuals were marking their race and ethnicity using census data. So that's what we're going to use for our prediction. And then we have the fire.resources library to convert our data to fire resources. So this is the main code. I have a bunch of typed classes here using Pydantic. You have an enum. So in the API, there's like an NPI1 for, this is, let me actually write it in here, for individuals and then for organizations. Largely, we don't really care about this because they're usually looking for a healthcare provider. Or at least I don't care about this. I want to find a doctor who can take care of my family and friends. So largely, I'm going to try to filter out for this NPI1. There's address to store all the addresses, taxonomy, there's identifiers, other names. And then these are enriched fields that we'll try to predict. And then this is because when you get information from the API, they're a little finicky. If you don't specify if you want like individuals versus organizations, it'll return both. So, and then the fields that are returned are obviously different for organizations and individuals. So what I did is I split the classes to have one for individuals. So this is the basic info for individual, and this is a entry for a individual. And then there's one for organization, and then there's one for MPPE entry organization. So that's kind of the basis of the model. And then if you go down here, what I do is I just store the entire raw JSON output. So I try to capture as much information as I can when querying the API, and it'll return ideally the exact same thing as you would see if you queried and received the raw API response. So that's what I have here. So I have a couple of functions. This basically goes and grabs the data from the API based on a user query. The user can use a first name or a last name, city, and state. And so it will usually query NPI1 if first name or last name is available. So do that. And then this is the query. Next, what it'll do is it will go ahead and parse that API response that you got up here, and it will convert it into those different objects. This converts sometimes. This here is our function for enriching the data. So after you get the data back, stored in our objects, what we actually do is we try to predict it. This is just predicting it based on the first and last name. Very basic. The language prediction is kind of hard coded. It's definitely not foolproof, but it is what it is. The main part is just predicting that race or ethnicity using that library. And then ultimately it'll just return the provider with the enriched data. That's most of it. This just prints the results. If I scroll down, this is the raw JSON just for troubleshooting. This ultimately, I figured I didn't care about the NPI2 results, so I filter anything that's not NPI1. And then this is my functions for converting it to fire. And then this creates the practitioner and practitioner role, and this prints the fire. So here is the main function that puts everything together. So it starts off by asking the user a first name of a provider, a last name of a provider, if you know them. I assume this is usually will not be used, but I just put it in there in case you wanted it. And then a city and state is where I would guess most people would find value in this, is like whatever city or state you're in, you're probably trying to find nearby providers of a certain ethnicity or what language they can speak. So city and state are inputs. And what it'll do is it'll go ahead and grab the raw data based on what the user entered. So the user can enter any number of these, and it will grab the data and store it as raw data, which is what we'd expect from the raw API. It'll print it. This is more so for troubleshooting purposes. And the next thing is it's going to filter out all of those entries that are of organization type. So if it's MPI2, it gets filtered out. And all we care about is the individuals that are returned. And then from there, what we would do is take all of the NPI1 data, which is individual providers, and parse it into our data models that we have at the very beginning. And it'll be in this object called MPI response. And then we're going to take the MPI response and we're going to run that enrichment function on there and try to predict the race and ethnicity of each of those providers. And then it was going to try to predict the language that that provider likely speaks. And that'll be stored back in the same object. And then lastly, we're just going to print the results of that in a nice way. That's not in the JSON object, so it's easy to read. And then we're going to take those results from MPI response, and then we're going to go ahead and convert all of that into our Fire objects, and then we're just going to print it. So that's how the function kind of works. And I'm just going to show a quick demo of what that looks like. So I'm going to do two demos. First one, I'm just going to use my own name, and I'm not going to enter state. This defaults to no. And so what it does here is, so you can see my user input is here. It's going to go ahead and return the raw JSON object, primarily for troubleshooting purposes. I can see what it looks like to make sure I can grab as much information as possible. This is a little nicer because it's more user-friendly. And then ultimately, and here's the predictions, by the way. So these were predicted using that library. This didn't come from the API. And then the very end here is what it'll look like when it's converted to Fire. And then, so that's one demo there. And let me show you another demo of like how I would expect it to be used. So let's say you're looking for a provider in your area. You don't know the first or last name, of course, because that's who you're looking for. But let's say you're in a city. I am in Fairfax. I'm going to use Fairfax in Virginia. Defaults to no. And what it's going to do is going to go ahead and search through everyone and find all those providers, filter out those organizations. So it's only individual providers. And then it's going to make predictions for every one of those providers returned in my city for the race and ethnicity that we think they are, and then the language that we think they may speak. So this takes some time. Oh, it looks like it's finished. I scroll all the way up. There's quite a few. I think there was like a, oh yeah, there's quite a bit. Oh, didn't mean to do that. I want to see how many results it returned. Oh, I keep scrolling past it. Oh, it's truncated it. So yeah, here's all the raw JSON objects. So a bunch of providers in Fairfax. I definitely need to do like some type of filtering. So here's some. You have an MPI number. You have this doctor over here. They are active. Prediction is they're African and Muslim. This is a pathology provider. This is Charles, Greater European British, dermatology. So yeah, this is the main thing. And if you go all the way to the bottom, it will, there's a lot of information. It will convert each one of those to a Fire resource. So ideally what you can do is take this and convert everything into Fire and then deposit it to a Firestore and then expose it as an API for other people to query. That's kind of the essence of the project. If you have any interests or comments, feedback about the project, I would love to hear it. This is probably going to be a pretty longitudinal project for myself. Trying to figure out how to solve this problem of quickly identifying individuals in my area that speak a certain language, but also further extending that eventually to finding resources in general for individuals who speak a certain language. All right, guys, thanks for watching. This was my fun on a Saturday. Hope you guys enjoy the rest of your weekend. Bye.